Hi, welcome back to Engineering Drawing. This is Dr. Vasu. We are going to see the projections of straight lines when the line is inclined to one plane. If you want to learn this and many more other interesting topics, please do subscribe this channel. If you like this lecture, please hit the like button. That will keep me motivated to create many such videos in the future. Now, let's see what this line is when it is inclined to one plane. So let's take a problem. A straight line AB is in HP. It is in the horizontal plane. Its one end A is 20 mm and B is 100 mm in front of VP respectively. That means A is 20 mm in front of VP, B is 100 mm in front of VP. Let's show the data as it is given. So the line is in HP. Okay, so what happens when it is in the HP? Its front view is on the reference line. So we have taken the front view we have taken one end A on the reference line, and also A dash B dash will be on the reference line. So we have fixed A dash, and B dash is also on this reference line somewhere, we don't know. Now A is 20 mm in front of VP. So we have drawn a line here at a marked a distance, and at a distance of 20 mm, we mark a point here and draw a projector through this A dash, and this point will be A, the top view of A. And point B is 100 mm in front of VP. So at a distance of 100 mm, we draw a line here, we may call it as the locus of B, and the top view of B must be lying somewhere here on this line. Okay, and its front view is measuring 90 mm. So the point B is top view is lying here. Coming to the front view A dash B dash, it is measuring 90 mm. So from A dash, we draw a line here at a distance of 90 mm. We mark 90 mm distance, and this will be the point B dash. Okay, so A dash B dash is fixed now. This is the point B dash. Now from B dash, draw a projector, and the top view must be lying on this projector, and also we know that the point B must be lying on this locus of B. So this intersection point will be the B here. Now join this A dash, join the top view of A and B by a straight line here. That will be the true length of the line, because the line is parallel to HP. The line is in HP, and its true length is seen in the top view, and we have to measure this length, and that's a true length. And also we can mark the inclination of this line with the VP. The inclination of the line with VP and the true length are measured like this. So these are the projections of the line, and can get the required data like this. Next, a straight line AB is parallel to VP. Okay, and its one end is 20 mm above HP and 15 mm in front of VP. So here let's take the reference line, and the point A is its one end. I call it as A. A is 20 mm above HP. Above the reference line at a height of 20 mm, I draw a line here. I call it as the locus of A. So the front view of A is lying somewhere here on this line, and I mark some point here. Okay, A dash is lying, and 15 mm in front of VP, in front of the reference line at a distance of 15 mm, we draw another line here. So the top view of A must be lying somewhere here on this line. So if you take a point here on this locus of A, that is at 20 mm above HP, this we call it as A dash. That is, we are fixing this point A dash. If you draw a projector from this onto the reference line and extend this on this projector, you must have the top view also. So this intersection point is A, the top view, because the point top view must be lying on this line also, on this line and on this projector. So this intersection point is A. Now we got the one end of the line. It is making a, and an angle of 30 degrees with HP. So it's making a 30 degrees angle with HP. We draw a line at a 30 degrees angle, right? And its a top view is 50 mm. That's all. We are not given the true length and we are asked to find the true length here. So we have drawn the line here at a 30 degrees angle, and we know that the line is parallel to VP. That means in the front view, you should get the true length of the line. Now, its a top view length is given. We know that the line is parallel to VP. That means its a top view must be parallel to the reference line, and we know A. So AB is parallel to the reference line. We draw a line here at 50 mm, a projector. So the point B must be lying on this projector somewhere. And we know that it is parallel to the reference line because the line is parallel to VP. So draw a line here parallel to the reference line, which is of 50 mm length, the top view length here 50 mm. So this is point B now. And we know that the front view and the top view of B dash must lie on the same projector. So from B, you draw a projector here, and that will be this intersection point will be the B dash, the front view of B. So like this, we can get the front view of the line, and here that itself is the true length of the line. You have to just measure the length of this line. That is the nothing but true length. Okay, so next one. A straight line AB of 75 mm is appearing to be 55 mm in the top view. Okay, so the true length of the line is given, that is 75 mm. It is appearing to be 55 in the top view. Its a top view length is given, and it is parallel to VP. This is the data given. Now, let's take the reference line here. Its one end is 15 mm above HP. So, and 10 mm in front of VP. So we have drawn a line parallel to the reference line at a distance of 10 mm, and its top view is lying on this line, and 10 mm in front of VP and 15 mm above HP. Okay. And one more thing, it's this is the top view. So I mark this point as A here, and at a distance of 55 mm, the length of its top view is given. So the top view length is marked here because AB is parallel to the reference line, right? And this is 55 mm. The top view length is 55 mm, and we know that the line is parallel to VP. So the top view is parallel to the reference line. So this is B. AB is 55 mm long and parallel to the reference line. So what else? Its end is A is 15 mm above HP. So at a height of 15 mm, we draw a line here, locus, and point A's front view must be lying somewhere here on this line. And also we got the top view of A. So if you draw a projector from this A, the A dash must be lying on this projector and also on this locus. So the intersection point is A dash. So we got A dash. Now you have to get a B dash. How? B and B dash must be lying on the same projector. So draw a projector from B here, and we got the projector. That means B dash must be lying somewhere here on this projector. Also, we know the length of this line 75 mm. The 75 is the true length of the line. So from A dash, we mark draw an arc here with the 75 mm radius, and this intersection point is nothing but the B dash, because B dash must be lying on this projector. So we got A dash and B dash, join it by a straight line. This is the 75 mm line we have drawn. And you can measure the angle with the HP here. This is the angle with the HP, theta. So like this, we can draw the projections of the line. Next, we take another line here, AB parallel to HP and making 30 degrees angle with HP. It is parallel to HP, but making 30 degrees angle with VP. Its front view is measuring, front view length is given, that is A dash, B dash, 65 mm. one end is 40 mm above HP and 30 mm in front of VP. Let's represent the data given. We're taking the reference line, and the A is, one end A is 40 mm above HP. So at a height of 40 mm, we have drawn a line, and on this locus somewhere its A dash must be lying. Also 30 mm in front of VP. So we draw a projector here. I have fixed the point, this one, and we call it as A dash. 30 mm in front of VP. So, and one more thing here, it is taken as 65 mm. The front view length is given, right? A dash, B dash. The front view length is given as 65 mm. So let's mark the front view here length because the line is parallel to HP. So parallel to the reference line. So we have marked 65 mm long here, and this is the B dash. This point, intersection point is B dash. So here, now draw a projector onto the reference line. Now the third point A is 30 mm in front of VP. So at a distance of 30 mm, we draw another line here, the locus, and we know that the top view of A must be lying here and also on this projector. So draw a projector here, and this intersection point is nothing but A, the top view. What else? Now we know that the line is making 30 degrees angle with VP. So at a 30 degrees angle, we have drawn this line. We draw a line here at a 30 degrees angle. So AB, the top view of B must be lying on this line somewhere. We don't, all right? Because we don't know the true length of the line, we just drawn the line here. And B is lying somewhere. And also, we know B dash. So from B dash, draw a projector, and this intersection point is nothing but the top view of B. So this intersection point is marked, and join this AB and highlight this. This AB is the top view and also the true length of the line because the line is parallel to HP. So this is the true length. You can measure that. Okay. Now, let's take another problem. A line AB 100 mm long is parallel to HP and 45 mm above it. Right. Draw the reference line, right? And its ends are A and B are 30 mm and 80 mm in front of VP. So here, let's represent this point A, that is 30 mm in front of VP. So from the reference line, we have taken a line here at 30 mm. So top view of A must be lying on this line, A. And B is lying at in 80 mm in front of VP. So at a distance of 80 mm, we draw another line. So top view of B must be lying on this line. Okay. Now, what else? We can represent, we take one point here, fix one point and call it as A. If you draw a projector onto this, this is a point A, position of A. And what else? The length of the line, true length of the line is given. So we know that this point B is lying on this line in the top view, and AB, the true length of the line is given as 100 mm and parallel to HP. That means in the top view, we will be able to see the true length of the line. So with a 100 mm radius, we draw an arc here cutting this locus. So this intersection point is nothing but B. Join AB by a straight line. This is 100 mm long. Join AB by a straight line. Okay. This is the top view. Now, draw a projector from B and extend this. This is the angle with the VP. The angle with the inclination with the VP is measured in the top view. Okay. Now, this is the angle. And what else? We have to draw the front view. Where is it? 40 mm, 45 mm above it. It is parallel to HP, and the line is 45 mm above the horizontal plane. So extend this A and B projectors through A and B are extended, and at a distance of 45 mm, we draw a horizontal line parallel to the reference line. So here the front view of this line must be lying on this. So what is it? A dash must lie here. So this point will be A dash. B and B dash must lie here. So this point is B dash. So this is A dash, B dash is the front view of the line. One. Highlight this. So you got the final projections of the line and you can measure the inclination with VP here. Okay. Now, next. Let's take another problem which is in the third quadrant here. A line AB 100 mm long has one of its end A 10 mm below HB and 15 mm behind VP. That means in the third quadrant. So let's draw the project reference line and 10 mm below HP and 15 mm behind VP. So at a distance of 15 mm behind VP, we'll be able to see the top view. Okay. In the top view, we see the above the reference line, we get the top view. So here, A must be lying on this locus. We may call it as locus because point A can be anywhere on this line. So what else? The point A is 10 mm below HP. So at a distance of 10 mm, we draw another line, okay, 10 mm, and A dash must be lying somewhere here on this line, okay. And we know that if you take a point, I fix a point here on the locus. So when you consider this point as A, draw a projector from this point onto this one, draw a projector. This intersection point here is nothing but A dash. So we got the one end of the line, A and A dash projectors are obtained. And the line is parallel to HP and inclined at 30 degrees angle to VP. So the line is inclined at 30 degrees to VP. That means in the top view, we will be able to see that 30 degrees angle. So at the 30 degrees angle, we draw a line here and mark the 100 mm long, because in the top view, we'll be able to see the true length and actual inclination of the line with VP. So 100 mm line is drawn and here this is point B. What else? We know that A, B and B dash must lie on the same projector. Draw a projector from B here and this is B dash because the line is parallel to HP. So it is given. So parallel to HP it is there. So in the front view, we'll be able to see that. So this A dash, B dash is the front view. Okay. And highlight this front view and top view. These are the projections of the line when it is in the third quadrant. Okay. So far we have seen the line inclined to one of the reference planes. In the next video, we are going to see when it is inclined to both the reference planes. So hope you understood this topic very well. And if you have any questions or suggestions, please do comment. Thank you.